I woke up to the sound to silence the cars. We're cutting like knives in a fist fight. And I found you with a bottle of wine, your head in the curtains and heart like the 4th of July. You swore and said we are not shining stars. This I know, I never said we are. Though I never been through hell like that, I've closed enough windows to know you can never look back. If you're lost and alone, or you're sinking like a stone, carry on. May your past be the sound of your feet upon the ground. Carry on, carry on, carry on. So I met up with some friends at the edge of the night at a bar off 75. And we talked and talked about how our parents will die, all our neighbors and wives. But I'd like to think I can cheat it all to make up for the times I've been cheated on. And it's nice to know when I was left for dead, I was found and I don't know these streets. I am not the ghost you ought to be. If you're lost and alone, know you're sinking like a stone. Carry on. May your past be the sound of your feet upon the ground. And carry on.
Class, settle down. Thank you. We start with a new topic today. The vector.
Vector? What's that?
What is it? Well, a vector is composed of two parts. It has magnitude and it has direction.
Vector? I hardly even know her.
On a coordinate plane, a vector can look like this. And a vector is made up of 2 points, point P and point Q. And to find vector V, you simply subtract Q minus. Okay, so now what we got here, we have vector V in the coordinate plane made up of points Q and points P. We talked about how to find vector V. You'll also notice that this vector V is made up of a horizontal component X and a vertical component Y. To find this component V, you add X to Y, tip the tail to find the diagonal, which becomes our vector V.
Yes, new high score. What?
Okay, so we have point P here, point Q here. To find vector V, you take Q minus P, 3 minus 2, 7 minus 5. That gets us vector V equaling 1, 2. Now we can transpose it to the origin. So you're going to put 1.2 on the map right there, make it a vector like that, and that's vector V on the coordinate plane. Now there are several things we can do to a vector. We can add a vector to another vector, and that's very simple. If we had another vector, let's say 2, 6, to add these two vectors together, you add the x's and you add the y's. So this creates a new vector of 3 and 8. We can subtract vectors doing the same thing, but just subtracting them. And then we can also add a scalar to a vector. So let's say we want to add a scalar to our vector v. V equals a comma b. We have lambda v equaling lambda a comma lambda b. So if we had an example with v equaling 2, 7, it'd be very simple. Let's say we have 5v. Very simple. We have 5, 2 and 5, 7. It's 3rd grade math. That's 10, 35. That's our new vector. Okay, the next thing we're going to talk about are two different basic properties of vector addition. We have the commutative law and the associative law. If we have vector v here and vector w here, v plus w is going to equal w plus v. This is very similar to the commutative law when we talk about regular addition of numbers. Associative law is also very similar to the regular associative law of numbers. If we're going to add this vector u into the mix, u plus vector v plus w is going to be the same thing as u plus v, adding on the w after that.
Hey, look, it's a pencil.
Our last topic of the day is the unit vector. What is the unit vector? Well, it's not too hard to understand. It's when we have a normal vector and we're trying to convert it into a unit of length. It's not concerning the length as much as the direction of the vector. The formula we use to find the unit vector is 1 over the magnitude of the vector times v. So if we have vector v here, which is 3, 5, we'll find the magnitude of that vector, which is 3 squared plus 5 squared. This is root 34. And if we use our formula right here, our new unit vector of v is going to be 1 over root 34 for vector v, which is 3, 5. We have our new vector, which is a unit vector of 3 over root 34, 5 over root 34. If no one has any more questions, we will now watch a short video that will help explain what I had talked about.
Hiya kids, I'm David Beard, the Science Peer. Let's learn about vectors. This is the distance formula. It shows the distance between 2 points, which is a vector. Oh my god. So let's do a problem. Let's do it. One of the points is going to be 4, 3, and one's going to be 10, 6. So what you do is you do the last point minus the first point plus squared plus 6 minus 3, which is the other point minus the other point squared. And you square root it. What is that? That is root 45. Math. Let's look at this visually. This is the same points we had before. Point P is 4, 3, point Q is 10, 6. So what do? You take the horizontal part, which is 6, and you square it, plus the vertical part, which is 3, and you square that. Then you square root that, and you get root 45. Science. Now we're going to learn about dot product. What is dot product? It is when you dot the two vectors. So here's the first vector, 3, 2, 6. The second one is 2, 4, and 1. So what do we do to get the dot product? We times the x components together plus the multiplied of the y components together right here plus the multiplied of the z components together. What do we get? We get 20. And I got that because I'm better than you. Hey kids, let's learn about the angle between two vectors. Remember how we learned how to find the distance between 2 points earlier? Well, that's magnitude, and we're going to use that here. So let's look at these two vectors, 1, 3, and 3, 5. To find the angle, you have the dot product between the two vectors on top of the magnitude multiplied by the other magnitude of the two vectors. So, and then you take the inverse cosine of that to find the angle. So with those two, you plug them in and get this. So let's plug that into our handy dandy calculator. Beep, boop, boop, bop, boop, boop, boop. We get 12.5 degrees. Let's look at our graph. 12.5 degrees. Let's learn about the projection of u along v. This is very fun stuff, guys. So the projection of u along v equals the dot product of u times v over the dot product of v times v times the entire vector v. With these vectors 1, 3, and 3, 5, let's plug this in. This would equal 18 over 34, and this would equal 3, 5, which in total equals 27 over 17, 45 over 17. What is this useful for? Who knows, but it's good to learn. Now we learn about the component of u along v. Let's use some 3D vectors. Our first vector is 1, 3, 2, and our second vector is 3, 5, 1. So what do you do to find this? You get u dot product times v over the vector magnitude of v. So let's plug that in. And you get this plus this over this, which equals 20 over root 14. Isn't that exciting, guys? Let's learn about cross product. how do you find a cross product between these two vectors? Well, you use the determinant of a matrix. No, not that matrix. This matrix, the fun matrix. So what do? You multiply 3 times 1 and then subtract 5 times 2 to get the first x component. Then you multiply 1 times 1 minus 3 times 2, but this time it's negative, and you get the y component. Then you multiply 1 times 5 minus 3 times 3 to get the z component, and you get this. Vectors.
What's wrong, Baxter?
Professor Victor, what are you doing here?
Walking to my car.
Well, it's just that I got my championship game coming up, and I cannot make my bank shot. Lost my rhythm. I don't want to be the embarrassment of my team. I don't know what to do.
I can help you.
Really?
So did you pay attention in class today?
No, nobody really did.
Oh, well, that's besides the point. See, the surprising thing is what we learn in math can actually be relevant to the real world.
Math is relevant?
Yeah, I know, it's surprising. You see, if you use vectors and magnitudes and how they are applied, it can actually help you with your game.
How so?
You see, that's a standard 10-foot basketball goal right there, okay? You're about 8 to 10 feet away from the goal. You calculate the magnitude of where you are to where you need to get. You can figure out how much force you need to put on the ball to get it in the hoop.
Wow, thanks. I'm going to go home and do some math.
You do that. Doesn't you know his car's the other way?
Yeah, it's that way. Huh.
Vectors. Don't think about it as change. What to do? Wait.
Yeah, got it? Yes? Yes! I superimpose the XYZ coordinate system on the basket. And so I put the basket at the center where the XY points are 0 and 0, but it has a height of 10 feet, so I put Z equal to 10. So that should be point Q. But where I'm at point P, where I'm 24 feet to the right of the basket, 8 feet away from the basket down. And the basketball, if I take into account the original position of it, is 5 feet above the ground. So my P point is 24 negative 8, 5. Now, if I just find the direction, use this equation Q minus P, I put in point Q and point P, I get this vector negative 24, 8, 5. So that's the direction. But to find the magnitude, I gotta use this equation. Root x squared plus y squared plus z squared. So I put in the components of the vector, negative 24 squared plus 8 squared plus 5 squared, all root of that is root 665. That's it. Got it.
But first, I gotta train.
Okay, folks, only 4.6 seconds remain in the state championship game. We are tied at 83, and Victoria Falls will inbound the ball. It will be Mark Smith. They clearly want to get it to Baxter Collins, their star player. And they get it to Baxter. He's got to hurry. He's going to put up the shot for the win! It's good! And Victoria Falls has won the championship as the students rush the court. Absolute pandemonium. Baxter Collins will be the most popular kid in school! Wow! Unbelievable! My goodness! Okay, so our next topic is the unit vector, and we use, whoa. Consuela, not yet. No,
No,
leave.
no, I clean. No,
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 leave.
no, no,
No.
I clean. No, no, no.
This is awkward. I'm filming. There you go.
I got the shot.
Be like.
Turns around.
No, that's the plasma thing.
Oh, sorry, that's what I meant.
Okay, that's good.
Vectors, direction, and magnitude.